Hi, good morning, everyone. Are there any questions for homework? Yes. What are the questions? Question 23. Is it from MCQ? From structure, question 23. That's page number? Okay. Page number 39. Question number 23 from the structured questions. Right? The first cyclotron was created by E.O. Lorentz in 1931. He obtained an expression for time t for a particle of charge q and mass m to complete a circular path in a uniform magnetic field of magnetic flux density p. The expression obtained by the Lorentz is given t equals to pi m over bq. Derive this expression. T is the time taken for it to move one circle in the magnetic field. So guys, I'll take F equals, the magnetic force will be F equals BQV. This is a force exerted by the magnetic field on a charge q. So if I use F equals ma for the particle moving in the circular path, F is BQV. M into A is V square over R. So one of the V's will cancel off. And if I get the V subjected, V equals B Q R over M. This is the speed. So if I use speed equal distance over time for the particle moving in the circle, speed equal distance over time. Speed is dq r over m. Distance is one circle, circumference of the circle, which is 2 pi r. Over the time taken is t. So this r here will cancel off with the r here. If I get the t subjected, that is going to be 2 pi m over bq. That is the time taken for the particle to move one circle in the magnetic field. Right? The next one. In Lorentz's cyclotron, an alternating potential difference was used to accelerate particles to high energies. Okay. Explain the significance of the expression obtained by Lorentz to the operation of cyclotron. Explain the significance of the expression obtained by Lorentz to operation of cyclotron. Now, significance of the expressions. For a 4 marker they have asked. So what is the significance? What are we getting here? T equals 2 pi m over bq. So guys, this t, the time taken to make a complete circle depends on the mass of the particle, magnetic field, and the charge of the particle. It doesn't depend on the speed of the particle. Correct? So we can speak about those points, right? The time taken to complete a circle depends on the mass and charge of the particle and the strength of the magnetic field. Full stop. Page number 39. Strength of the magnetic field. Full stop. It doesn't depend on, it doesn't depend on the speed of the particle. It doesn't depend on the speed of the particle. Full stop. Time taken is inversely proportional. Time taken is inversely proportional to the strength of the magnetic field. Strength of the magnetic field. For a given particle. Time taken is inversely proportional to the strength of the magnetic field for a given particle. That's enough. In a cyclotron, the next part. In which Lorenz's expression applies, protons were accelerated to a speed of 1.5 into 10⁻⁷ meters per second. Determine the time taken to accelerate a proton to the speed from rest. Magnetic flux density is given. Accelerating potential difference is given. We have the equation T equals 2 pi mo dq. That is what we got in the previous part. The question is, determine the time taken to accelerate a proton to the speed from rest. Magnetic flux density is given. Accelerating potential difference is given. Speed is given. Okay. Right. I can use I can see what is the acceleration by using F equals ma. F is or else, hold on. Yeah, that is one way. Or else if you're using, give a minute. right? You can use F equals EQ to find the force, and then MA and find the A. A equals EQ over M. So the acceleration will be electric field also we don't know, right? Work done by the field is
We just use to by MODP.
that's going to give you the time taken to move in one circle. Here they are asking what is the speed, what is the time taken for the speed to go up to 1.5 into 10 to the power 7 from rest, not the time taken to move in one circle. Read the question again. Protons were accelerated to a speed of 1.5 into 10 to the power 7 meters per second. Determine the time taken to accelerate a proton to the speed from rest. Flux density is given 1.6 Tesla.
So
Hmm.
you find how many protons are being charged into the number of protons that you pass. They multiply by the time.
What?
How many number of protons are being passed and multiply by the time. There are many protons passing, right?
Okay.
So find the number of protons being passed and you multiply that time. So there's new kinetic energy also being attracted.
So how is E equal V over D, sir?
Potential difference over distance. Hold on.
No, I'm asking how did you get it from B square equal U square plus 2AS?
No, 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 not from that. No, that's a different one I have.
Okay, that's
Give me a minute. Hold on.
So,
Hmm.
so can we use F equals B, sorry, can we use PQ equals F square over R to find R because we have everything else and then put S equals UD from this thing. From the diagonal equations and put each speed of 0, right? To find
The magnetic flux density is actually not needed here. The acceleration happens from the electric field. So that this time that we have got in the previous part, this is the time taken for a particle to move in one circle. Here, what are they asking is, there is a particle, proton. What is the time taken to accelerate that proton to this speed? From rest is the question, not the time taken to move in one circle. It's a different question. I mean, that will give you the magnetic force when the particle is moving at a constant speed. Here they are asking, what is the time taken to accelerate the particle from 0 to that speed? That is done by the electric field. Okay. That is the magnetic force. Okay. Anyway, we'll come back to this question. What are the MCQ questions we have done? We have to do. Starting from question 2. Let's turn to the MCQs, page number 51. You can. One.
one cycle has 2 passes, right? So
Hmm.
so aren't we doing part B, sir?
Wait. We'll come back to that question. Wait. First, we'll go through the MCQs and we'll get back to that. Question number 2. Which of the following statements is true for a cyclotron? The cyclotron can be used to accelerate neutrons. It uses a magnetic field to increase the speed of particles. It uses an alternating PD at a constant frequency. It uses an electric field to keep particles moving in a circular path. What is your answer? It uses an alternating potential difference at constant frequency. The answer is C. The 10th one. A nucleus of element X emits an they are neutral. They don't have a charge.
So what's the answer for question number 2, sir?
Which one?
Question number 2.
2, the answer is C. Question number 2, the answer is C. 10th one. A nucleus of element X emits an alpha particle to produce a nucleus 23391Y after emitting an alpha particle. Which of the following is the correct nucleon structure of element X? So guys, after emitting an alpha particle, you have got 23391Y. When you emit an alpha particle from your O levels, you know the proton number decreases by 2. The nucleon number decreases by 4. So 233 here means it should be 237 here. It's 91 here means it should be 93 here. So that means it should have 93 protons and the number of neutrons will be 237 minus 93, which is 144. The answer is B. Correct? Have you got this answer? Right. 10 is B. 14th one. In the early 20th century, experiments were carried out to measure the scattering of alpha particles after striking thin gold foil. Can you take one of those and pass it around? In the early 20th century, experiments were carried out to measure the scattering of alpha particles after striking thin gold foil. Which of the following could not be concluded from the results of these experiments? The nucleus is charged. The nucleus contain most of the mass of the atom. Correct. The nucleus contains neutrons and protons. The nucleus is very small.
C, right?
C, yes. You only got to know that nucleus is charged. You didn't know whether it is positive or negative or what. Okay. Correct. 15th one. A proton is accelerated by a uniform electric field. After time t, the speed of the proton has increased by delta V. A helium nucleus is accelerated by the same electric field. After what time will the helium nucleus achieve the same change in speed? A proton is accelerated by uniform electric field. After time t, the speed of the proton has increased by delta V. After time t. So if I use F equals ma for this particle, whichever the particle which is accelerating, F is equal to E into Q, mass into acceleration is delta V over T. Okay. Anyone holding it? Okay. Okay. EQ equals M into delta V over T. A proton is accelerated by uniform electric field after time t. So if I get the t here subjected, t is equal to m into delta v over EQ. This is the time taken to accelerate. The time taken to change the speed by delta v. Listen to me carefully. So guys, for a proton, the time taken is t. Okay. So the time taken depends on its mass, change in velocity, electric field strength, and the charge. Correct? So if we compare a proton and a helium nucleus, a proton is accelerated by uniform electric field. After time t, the speed of the proton has increased by delta v. Fine. A helium nucleus is accelerated by the same electric field. So same electric field is the same. Okay. After what time will the helium nucleus achieve the same changing speed, same delta v, same change in speed? So basically the time taken depends on the mass and the charge. Correct? So comparing to the proton, the mass of the helium nucleus is 4 times. Agree? Comparing to the charge of the proton, the charge of the helium nucleus is 2 times. Am I right? So the mass is 4 times, charge is 2 times. So the time taken for the helium nucleus will be
Excuse me, sir.
comparing. Yeah.
So, but we don't know the exact what do you call the number of protons and neutrons, right? In that specific.
Helium nucleus.
No, they said a proton, right? We don't know what they're talking, which proton they're talking about.
What?
Ah, okay, sorry, nothing.
Wow. What are you telling?
Nothing.
What is the time in your country now?
So it's 6 o'clock.
No wonder. Now listen, guys. So this helium nucleus has 2 protons and 2 neutrons. So it has a mass 4 times the mass of the proton and 2 times the charge of the proton. So the time taken for the helium nucleus will be comparing to T into 4/2, which is 2T. My answer is B. Do you understand? Since the mass is 4 times, the time taken will be 4 times. Since the charge is 2 times, the mass time taken will be half. So 4 into half, both taken into account, it will be 2T. Understood? Putting it in.
So
Right.
how do you
But-
get T into 4?
Because the mass is 4 times. Now it's like this, no, the time taken is directly proportional to the mass and inversely proportional to the charge. So if the mass is 4 times, the time taken will be 4 times. If the charge is 2 times, the time taken will be half. So it is, there are 2 effects here. It's becoming 4 times due to the change in mass, half due to the change in charge. So it's 4 into half, which is 2. Any questions?
No, sir.
Question number 20. In a cyclotron, a charged particle is accelerated in a spiral path. Okay. Which of the following increases as the radius of the spiral path increases? Which of the following increases as the radius of the spiral path increases? The frequency of the alternating PD across the D is no, that's a constant frequency. The magnetic flux density acting perpendicularly to the spiral path, magnetic flux density doesn't change. The potential difference between the D is the velocity of the charged particles. What is your answer? Huh? What is the equation here we use for the do you remember this equation? V equals BQR over M. Correct? So BQ equals MV square over R. So BQR over M equals V. So as the radius increases, we know it goes in a spiral path. B is a constant magnetic field, magnetic flux density is constant, charge of the particle is NV constant, mass of the particle is NV constant. So as the R increases, what increases? The speed increases. No, not really. If that's the case, it has to be a constant speed. Here the speed keeps increasing because of the so the answer is the velocity of the charged particle. The answer is D. So just mark the answer. No, it's a constant potential. Yeah. No, the potential difference is applied between these two Ds. That is constant. No? That the potential difference between the Ds is a constant. Which of the following units is equivalent to Farad? Farad is capacitance, right? Capacitance Q equals CV. So C equals Q over V. Q is coulombs. Coulombs over volts. Coulombs per volts. The answer is A. Coulombs per volt. Correct? What's next? 23rd one. Which of the following is a valid conclusion from alpha particle scattering experiment? Atoms contain positive and negative charge distributed evenly. No. The nucleus of an atom contains protons and neutrons. The nucleus of an atom is very small compared to the size of the atom. Correct. C. Atoms contain very little empty space. No. The answer is C. Okay. Any questions? 26th one. A LINAC is a particle accelerator. It consists of drift tubes of increasing length with potential difference applied between them. Which of the following is the reason the drift tubes are increasing length? So that the PD can have a constant frequency. That's correct. So that the particle gains the same amount of energy in each tube? No. So that the PD between the tubes increases for each successive tube? No. So that the time spent in each successive tubes increases? No, it is the same. The answer is A. Frequency is constant for the alternating voltage. What else? 33rd. A charged particle is accelerated in a spiral path in a cyclotron. Which of the following changes would increase the amount of energy transferred to the particle as it travels through 360 degrees? What will increase the amount of energy? Transferred to the particle as it travels through 360 degrees. Increase in the distance between the Ds. Increase in the frequency of the potential difference across the Ds. R equals MV over BQ. Yeah, putting it that here. Increase in the frequency of the potential difference across the Ds. Increase in the strength of the magnetic field within the Ds. Increase in the maximum potential difference across the Ds. Give me your answer. What is your answer? D. Increase in the maximum potential difference across the Ds. Is it? Yes, that will definitely increase the speed gained by the particles. So that has to be D.
If a negatively charged particle gets attracted to the nucleus, then how will it go back in How will it
Negative particles.
Yeah, like there is a theory like that. Even negative charge particles can be reflected back from the path they came after hitting the nucleus.
Where did you see that?
That's the theory, right? Like even like
No,
even
in the you're talking about the gold foil experiment.
yeah, like yeah, the one from which they determine that atom is mostly in space and it's not that.
Yeah, that is
gold foil, right?
yeah gold foil experiment.
Yeah, so that's the
So in that alpha particles are what's fired right towards the gold foil. So alpha particles are positively charged.
yeah, that's true. But isn't that they could not determine whether the nucleus was positively or negative?
Because they didn't know that the alpha particle is positive or negative
They
at that time. So that is the reason you don't know whether it is exactly positive or negative. You just know that it is having the same charge as the particle which is fired, but you didn't know what it is.
otherwise they would have known that the nucleus was
Correct.
positive. So then why did they try to discover the alpha particle?
I have no idea. I was not living during that time. Okay, guys, what's next? Anything else? No, right? Fine. I have given you another tube. Please take that. A theory tube. I will come back to that.
So you didn't send by Gmail, sir?
Huh?
We didn't get it by mail, sir?
You didn't get it in the mail?
No, sir.
Give me a minute. Check your mail for the week before last or something. I have sent this earlier.
No, so all are these tubes are the nuclear physics.
Okay.
Nuclear and particle physics.
Yeah, new. Just see there should be a particle physics. Acute particle physics. No.
No, sir. No.
Hold on. Give me a minute. Guys online, the mail has been mailed for you. I mean, the tube has been mailed for you now. Can you please check? Please check your mail. Guys, can you go to question number 23 again? Question number 23. Question number 23. What we started today. Can you all read the question again? Okay. Casey, look at this. What are they saying is in a cyclotron in which Lorenz's expression applies, protons were accelerated to a speed of 1.5 into 10 to the power 7 meters per second. Did you get the answer? You have a final answer. What is your final answer? Okay, let's see. Okay, now they are getting taken the speed to the final speed of 1.5 into 10 to the power 7 meters per second. That is the final speed of the proton. Determine the time taken to accelerate a proton to this speed from rest. Magnetic flux density is 1.6 Tesla. Accelerating potential difference is 13 kilovolts. So that means the potential difference between the D's is 13 kilovolts. Correct? So that means when the particle is accelerated between the D's once, it will be gaining an energy of E equals VQ. No? Potential difference is 13 kilovolts, which is 13,000. Charge is 1.6 into 10 to the power minus 19 for a proton. So the energy that it will be gaining in one acceleration is 13,000 into 1.6 into 10 to the power minus 19. 2.08 into 10 to the power minus 15 joules. This is the energy it will be gaining in one acceleration. Okay. When it is crossing once through the D's, this is the energy it will be gaining. Okay. The final energy that it has gained, if I take it as E final, that is half mv square. You know the final speed? Half into what is the mass of a proton? 1.67 into 10 to the power minus 27 into the speed is 1.5 into 10 to the power 7. That's squared. So I'll take this as EF, the final speed, half into 1.67 into 10 to the power minus 27 into 1.5 into 10 to the power 7 square. That's 1.87875 into 10 to the power minus 13 joules. Correct? Listen to me carefully. This is the final energy the proton has gained. When it is accelerated once between the PD, it gains this much of energy. So to be having this final energy, how many times should it be accelerated? So the number of times it should be accelerated between the D's, I can find it. 2.08 into 10 to the power minus 15 divided by 1.87875 into 10 to the power minus 13. This will tell you how many times it needs to be accelerated between the D's. Yeah. Which is, no, it's other way around. Final energy is this. The final energy is 1.87875. That divided by the energy that you get in one is 2.08 into 10 to the power minus 15. That will give you 90.32. I repeat, listen. When it is accelerated once between the D's, it gets this much of energy. So every time it is accelerated between the D's, it gets an energy of 2.08 into 10 to the power minus 15 joules. So how many times it should be accelerated between the D's to get this final energy? Is the final energy divided by the energy that you are gaining in one acceleration. Am I right? So that means this should be accelerated 90.32 times. I'll take it as 90 times. Correct? That means how many rounds? It's not going to make a difference. Small difference. Okay? So the number of rounds needed will be, number of circles needed will be, number of rounds will be 45. So you have to go around 45 circles. Okay. So now I can use the previous equation, T equals 2 pi m, 2 pi mo bq. Now in one round, the particle get accelerated twice, right? Correct? So if you want to get accelerated 90 times, you need to go in 45 rounds. Yeah, because of it gets accelerated from here to here. It gets accelerated from here to here and gains a speed. It goes with that speed. And then again, it accelerates from here to here. So within a circle, two accelerations happen. So if you want to get accelerated 90 times, that means you have to go around 45 times. Correct? So now the time taken for one round is going to be 2 pi mo bq, which is 2 pi m is 1.67 into 10 to the power minus 27. B is 1.6. Q is also 1.6 into 10 to the power minus 19. This will give you the time taken for one round. That is 4.099. into 10 to the power minus 8 seconds. So for 45 rounds, the time taken will be that t into 45. 1.84 into 10 to the power minus 6 seconds. Forgot this answer? Is it your answer? Good, very good. This is what you were trying to tell earlier, is it? But you were telling something else.
Same last previous tutor was the same question. Same.
You were telling about number of protons.
Yeah, I missed that number.
Oh.
Same proton that I
Yeah, so that's what I didn't want to listen to what you told. You were talking about number of protons. So we are talking here about one proton going around. Okay. Sorry, I didn't get it. Yeah. In one round, 2 passes.
This is a very hard question.
Fine. Fine, okay. Guys, take the new tweet. I believe the people online, we have received the tweet now at least. So please leave it there. Leave it.
Can you go back to part A for recycling?
So why did you suddenly send tweets instead of writing notes?
It's a very theoretical topic, this part. So I don't want to just waste my time on that. We can just go through it. We will do the questions. Okay. Oh, it depends on the topic. There are certain topics there is no much theory. Okay. Right, guys. Take the tute, particle physics. From the textbook, the notes are. Let's quickly go through it. Later. Right. Creation. The implication from most creation stories is that, go follow the notes. Follow the notes. Page number 1. The implication from most creation stories is that from nothing, the material of the earth was brought into being by an unexplained entity. However, one of Einstein's most important theories suggests exactly this. Matter can appear where previously there was nothing but energy. Energy can be transformed to matter. Matter and energy are regularly interchanged in the universe according to his well-known equation E equals mc squared. Okay. So Einstein says matter can be converted to energy and energy can be converted to matter. Okay. The bridge between energy and matter is E equals mc squared, where E is the energy, m is the mass, c is the speed of light. In this equation, multiplying the mass of an object by the square of the speed of light, it gives the equivalent amount of energy. So the energy equivalent to the mass is given by E equals mc squared. Given a suitable quantity of energy, such as that in a gamma ray photo, particles can spontaneously appear and the energy disappears from existence. Okay. Particles can spontaneously appear and the energy can disappear from existence. Energy can be converted to particles. This is so common in the universe that it. Yeah. Tell me.
That's it. Sorry. Mistake.
This is so common in the universe that it should not surprise us. The reason it is that these events only happen on a subatomic scale. So we cannot detect them without complex machines. A gamma ray photon converts into an electron and a positron. A positron is an anti-electron that has an identical mass to an electron. So we'll speak about it later. Calculate the frequency of the gamma ray photon. Calculate the frequency of the gamma ray photon. The mass of the electron is given 9.11 into 10 to the power minus 31 kilogram. Can you do that? A gamma ray photon converts into an electron and a positron. Calculate the frequency of the gamma ray photon. So guys, the energy equivalent is given by E equals mc square. Okay, what are they saying is a gamma ray photon, a gamma photon converts into an electron and a positron. Electron and a positron. So what is a positron? It is also a particle with the same mass as electron, but electron is negatively charged. Positron is positively charged. Okay. So what is the energy of the electron? Electron will have a energy equivalence of mc square. Mass of the electron is 9.11 into 10 to the power minus 31 into 3 into 10 to the power 8 square. Okay. So the energy equivalent to the mass of the electron is this much, which is 9.11.
So what's the difference between a proton and a positron then? If a positron is positive.
Masses are different. Okay. Mass of a positron is the same
That
as
means
the mass.
that means it's zero almost, right?
Yeah, very close to
Negligible, you
zero.
can say. Yeah.
9. Yeah. So guys, this will give you an energy of 8.199 into 10 to the power minus 14 joules. Do you agree with me? No. Yeah. This is the energy of the electron. So if you take the energy of the positron, it will also be the same because positron also has the same mass. So the energy equivalence for the positron will also be the same. So the total energy of the electron and the positron will be 8.199 into 10 to the power minus 14 multiplied by 2, 1.6398 into 10 to the power minus 13 joules. Am I right? This is the energy, total energy of the electron and the positron. That means the gamma ray photon is what getting converted to electron and the positron means the gamma ray photon has this much of energy. So for the gamma ray photon, if I use E equals HF, so remember this, right? E is equal to 1.6398 into 10 to the power minus 13. And it is the Planck constant, which is 6.63 into 10 to the power minus 34. That into the frequency is what we are told to find. From here, you can find the frequency. Which is 2.47 into 10 to the power 20 hertz.
Just multiply the mass by each step, right?
Sorry?
So we can just multiply the mass by each step, right?
Mass by?
Because they want the same mass also. we can
Come again?
Instead of multiplying the energy, if we multiply the mass, it's okay.
Ah, yeah, correct. Correct. Same thing.
true matter in the universe and it will not stay. This is such conversions happen, right? Fast where energy demand and some better. All of those are because there's not enough for too much energy.
When it's unstable.
So always the universe tries to maintain some sort of mass energy balance.
Correct.
So when will the next Big Bang be probably?
It's like this. We actually learn. We speak about this in the unit 5. The ultimate fate of the universe. Yeah, on the astronomy. So keep the surprise until then. Okay, but anyway, there's no exact answer for that. It depends on the. Have you heard of something called dark matter?
Yeah.
So it depends on the amount of dark matter available in the universe. But no scientist knows exactly how much dark matter is there. So it depends on that. What is ultimately going to happen will decide.
So will there ever be a situation where all the mass converts to energy?
Depends. That is all. That also depends on the amount of dark matter. Okay, right. Antimatter is opposite charge, same mass. So if you take the electron, it has a certain charge and negative charge and a mass. So there's something called anti-electron, which is positively charged, same mass.
Human body is positively or negatively charged.
Human body doesn't have a charge.
So there's no antiparticle.
Now you're asking about if you keep on breaking it down, then you will end up to a quark or an anti-quark or something. That I don't know. Human body is made of what? Okay, fine. Get back to work. Page 2. This reaction is known as electron-positron pair production. Okay. In terms of momentum, in momentum terms, it is just like an explosion. Initially, only the photon existed. So there was some linear momentum. Along this initial direction, these components of momentum must sum to the same total as the photon had. Perpendicular to the initial momentum, the electron and positron that were produced must have equal and opposite components of momentum, so that in this direction it will still total 0 afterwards. So yes, trying to say during this conversion the momentum will remain conserved. In any reaction, the total combination of matter energy must be conserved. If we add the energy equivalent of all matter particles with the energies before and after the reaction, the number must be equal. Highlight that part. Okay, in any reaction, the total combination of matter energy must be conserved. Mass alone is not conserved, energy alone is not conserved. Mass energy combination is conserved. If we add the energy equivalent of all matter particles with the energies before and after the reaction, the numbers must be equal.
Should we change to any nuclear reaction? Normal reactions are
Not really. Not really.
so we have just been assuming one.
Yes. There can be slight changes.
But it's significant only nuclear.
Yeah. Fine. Annihilation. Matter can appear spontaneously through a conversion from energy. Okay. In the same way, energy can appear through the disappearance of mass. Mass can be converted to energy as well. This is the source of energy in nuclear fission and fusion, which is what we are going to learn. This is the source of energy in the nuclear fission and fusion, where the mass is converted to energy. In both reactions, the sum of masses of all matter involved before the reaction is greater than the sum of masses afterwards. This mass difference is what converted to energy that we will speak in nuclear reactions later. In a nuclear power station, we extract this energy as heat and use it to drive turbines to generate electricity. Fine. If a particle and its antiparticle meet, okay, we'll see what is antiparticles. They will disappear to be replaced by the equivalent energy. We call this interaction annihilation. Highlight that part. What is annihilation? If a particle and its antiparticle meet, they will disappear to be replaced by the equivalent energy. We call this interaction as annihilation. This reaction was supposedly the main power source to drive the Starship Enterprise. Blah, 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 not necessary. Annihilation reactors could not be used as a power source of Earth, on Earth, as an antimatter exists so rarely. Right, let's turn to the next page. Just know that an annihilation means a particle and its antiparticle combining together is known as annihilation. To what I know, no. Okay.
So then how is it there if it can't be created?
Natural. That you have to go before the Big Bang and question that. So where did that come? Okay, right. Question 3. Sorry, page 3. Electron volt units. Listen to this part carefully. This is something important. We have seen the electron volt as a unit for very small amounts of energy. Okay. So guys, 1 electron volt means, 1.6 into 10 to the power minus 19 joules. To convert electron volts to joules, you multiply by the charge of an electron. Remember that 1 electron volt is the amount of energy gained by an electron when it is accelerated through a potential difference of 1 volt. That is 1 electron volt. This is equivalent to 1.6 into 10 to the power minus 19 joules. So it is a very small amount of energy, even in particle physics terms. It's a very small amount of energy. It is common for particles to have millions or even billions of electron volts. Okay. For this reason, we often use mega electron volts, MeV, and giga electron volts as units for energy in particle interactions. Okay. Just common sense, since this electron volt is a very small amount, usually this mega electron volts and giga electron volts are used. The atomic mass unit is not an SI unit. It's not an SI unit, it's not in kilograms, but is often used in particle interactions, as it is usually easier to understand that. Understand. 1U is also equal to 1U is equal to 1.66 into 10 to the power minus 27 kilograms. The atomic mass unit. As we know that energy and masses are connected by the equation E equals mc square, we can also have mass units which are measures of E over c square. Listen to this part carefully. We can also have mass units which are measures of E over c square, such as mega electron volts over c square or giga electron volts over c square. 1U of mass is equivalent to about 931.5 mega electron volts over c square. So now we are going to speak about a new unit for mass. Okay. Mass is sometimes, now since E equals mc square, m is also equal to E over c square. correct? So they are going to come up with another unit for the mass, which is in energy over c square, either mega electron volts over c square or giga electron volts over c square. So there will be instances where you will have to convert this into kilograms or kilograms into this. So I'll explain you with an example. Read the first one. In a positron with kinetic energy, 2.2 mega electron volts collides with an electron at rest, and they annihilate each other. Positron with a kinetic energy of 2.2 mega electron volts collides with an electron which is at rest, and they annihilate each other. That means they combine together. Calculate the energy of each of the two identical gamma photons produced as a result of this annihilation. Calculate the frequency of these gamma photons. Can you give a try? Do the part A and give me an answer. Only the part A. Okay. Right. Guys, the positron with kinetic energy 2.2 mega electron volts collides with an electron at rest, and they annihilate each other. Calculate the energy of each of the two gamma photons produced as a result of the annihilation. Now listen to me. This positron and the electron, they were masses. They join together, annihilate, and the mass disappears, becomes energy. Okay. Originally, before the annihilation, the positron had a kinetic energy 2.2 mega electron volts. That energy will be converted to gamma ray photons energy. Plus, this positron and the electron had mass, right? That mass will be converted to energy as well, right? Okay. So the total energy in the picture is going to be E, if I use E equals mc square. Mass of the proton is, anyway, we did in the previous part, right? I'll make use of that. We used E equals mc square, and we found that the energy is 8.1, energy is 1.6398 into 10 to the power minus 30. 1.6398 for both. 1.6398 into 10 to the power minus 13 joules. Correct? No. Wait, darling. Wait. This is 1.6398 10 to the power minus 13 joules is the energy equivalent to the positron and the electron. If you use E equals mc square for the positron and the electron, and if you combine them together, this is the answer, right? 1.6398 10 to the power minus 13 joules. This is the energy equivalent to the mass of positron and electron. Plus, so the E total now available will be this 1.6398 into 10 to the power minus 13 joules plus the kinetic energy of the positron, which is 2.2 mega electron volts, which is 2.2 into 10 to the power 6 electron volts into 1.6 into 10 to the power minus 19 joules. This is the total energy of the two gamma ray photons, which is going to be 5.1598 into 10 to the power minus 13 joule. This is the energy of the two gamma ray photons. The question says, calculate the energy of the two identical gamma photons produced as a result of the annihilation. So there are two gamma ray photons produced. Okay. So the energy, they're asking to calculate the energy of each of the two identical. So these are the two, both having this much energy total. So the energy of one gamma ray photon will be, energy of one will be this divided by 5.1598 into 10 to the power minus 13 divided by 2. Hold on, give me a minute. 2.5799 into 10 to the power minus 13 joules is my answer. Yes, what is your question? No. They are combining together, forming two gamma ray photons.
So how can you take the energies? Right, by 2 joules and energies for the positron.
Yeah.
So you take positron and
Positrons mass gets converted to energy. Electrons mass gets converted to energy. And the positrons kinetic energy, that also gets converted to gamma ray photons energy. The total mass and energy before the reaction will be equal to the total energy after the reaction. Huh? That is equal, that is the theory. Energy, that is what we just read now. The mass energy combination is constant, conserved. So before this annihilation happens, whatever the mass and energy combined together will be equal to the total energy after. Okay. That is a gamma ray photon which converted to correct. But here it says a positron with no. It's a different story. You know, one is stationary, one is going and collide. So there has been two gamma ray photons. So we don't know the frequency. Frequency can be different. Okay. So anyway, the next part is they're asking for the frequency of these gamma ray photons.
So what I don't understand is why are you dividing it by 2?
A positron with kinetic energy 2.2 mega electron volts goes and collides with an electron which is at rest. They annihilate. Calculate the energy of each of the two identical gamma photons produced. The question says two gamma photons are produced. What we found here is the total energy which is produced. So the question says there are two gamma ray photons and they are asking for the energy of one gamma ray photon. So I divided it by 2. Okay.
Can't we apply the equation? E minus 6 divided by E minus the energy of the positron plus E minus the.
E, what do you mean by the E?
Sorry. E is the energy of both the gamma photons.
Okay.
So then E minus the kinetic energy of the positron into 2 equals C square into there is an n which is minus 1.678 to the power minus 27.
So are you getting the answer? Are you getting? I'll check it. Wait. Right, guys, read the next one. In 1977, in an accelerator at Fermilab,
So the frequency,
you use E equals HF and find it. I'll leave it to you. Just use E equals HF. So you know the E, you know the H, you can find the F, right? Okay.
After repetition, all the images are
Sorry?
after repetition and radiation.
It's just energy, no mass. There are 2 gamma ray photons. So energy and mass which was there is completely converted to energy.
So in this case, you have the kinetic energy of the
0. Yeah, it was at rest now. So I have considered the kinetic energy of the positron plus the energy corresponding to their masses is what getting converted to energy. So for the frequency should be used the total energy or energy of one gamma photon. E has to be the energy of one gamma ray photon because you are using the one photon. E equals HF, you use it for the one photon. Right, the next one. In 1977, in an accelerator at Fermilab, the upsilon particle was discovered. Its mass was determined as 9.46 giga electron volts over c square. What is the mass of this in kilograms? 9.46 giga electron volts over c square. Okay. How do you convert giga electron to convert giga electron volts to electron volts? I'll multiply by 10 to the power 9. Then it becomes 9.46 into 10 to the power 9 electron volts over c square. Okay. Then what is to convert electron volts to joules? We have to multiply by 9.46 into 10 to the power 9. To convert electron volts to joule, you multiply by 1.6 into 10 to the power minus 90 over c square. C is 3 into 10 to the power 8. 3 into 10 to the power 8 square. This will give you the mass in kilograms. Understood? Get the value?
So could you decrease the size so we can't see what's on the left? Thank you.
Giga electron volts, giga to convert to giga electron volts to electron volts, I multiply by 10 to the power 9. Then electron volts to convert to joules, I multiply by. No, this is in kilograms this time. (1.68 into 10 to the power minus 26). Okay. Okay, that's how you convert giga electron volts over c square to kilograms. Okay. There's another one on the next page, page 4. You can do that and go for a break. We'll do this and go for a break. Can you? Page number 4. A gamma ray photon traveling through space spontaneously converts into an electron and a positron. Explain why the two new particles must move in opposite directions to each other. Because the momentum is conserved. So now, if the gamma ray photon was traveling in a particular direction, okay, momentum is, it's like a explosion happening suddenly. No. Now, initially before the collision, momentum is 0. So after collision, if you want the momentum to be conserved, if this is moving with a certain momentum, the other particle has to be moving exactly in the opposite direction with the same momentum. Then only the total momentum will be 0, right? Yes or no? So for the momentum to be conserved after, similar to an explosion. So right, explain why the two new particles must move in opposite directions to each other. For the momentum to be conserved, the two particles should have equal momentum in opposite directions. Okay, read the next one. Just leave that. Leave that. Take the tube. Page number 16. Page number 16, question number 10, part A. You can go for a break and then come back and do this one. Question number 10, only the part A, page 16. Okay. No. That is what you think. No. What you think is wrong. Right, guys. Question number 10. Okay. The proton and antiproton collider was a large particle accelerator. An experiment using this proved the existence of a particle called a Z boson. Z boson. The mass of this is 91 giga-electron volts over C square. Show that the mass of this particle is nearly 100 times greater than the mass of the proton. Can you? So convert this into kilograms and then show that it is approximately 100 times the mass of a proton. Mass of a proton is 1.66 into 10 to the power minus 27 kilograms. Correct? Yeah, they're nice like that. So 91 giga-electron volts over C square will be 91 into 10 to the power 9 to convert giga-electron volts to electron volts into 1.6 into 10 to the power minus 19 over C square, which is 3 into 10 to the power 8 square. These are mass in kilograms. Which is 1.6177. 1.6178. I'll take 4 decimal places into 10 to the power minus 25 kilograms. These are mass of the particle, whatever they are telling, whatever boson or monson or whatever. Okay. Then how many times it is? If I take it as n, 1.6178 into 10 to the power minus 25. That divided by the mass of a proton, which is 1.66 into 10 to the power minus 27. That is 97.5, which is nearly 100 times is what they are telling you. So yes, it is about 97.5 times the mass of the proton. Okay, easy marks. Okay, any questions? 1.66, no? It's given in the data sheet, whatever it is, won't make a big difference. Right, and then guys, page number 20. Page number 20. Question number 12, part C. Can you please? Page 20, question 12, part C. A website states the rest mass of a muon particle is 106 mega electron volts over C square, which is a little over 200 times that of an electron. Deduce whether this statement is correct or not. So very similar to the previous one.
use whether it is actually 200 times that of the electron.
A little over that.
So it's confirmed that this is the mass, right? You don't need to confirm.
Correct. So convert 106 mega electron volts over c square to kilograms. 106 mega electron volts to electron volts, you multiply by 10 to the power 6. Electron volts, you multiply by 1.6 into 10 to the power minus 19. 3 into 10 to the power 8 square. That gives you the mass. .8844 into 10 to the power minus 28 kilograms. This is the mass of that particle in kilograms. Okay. Yeah, Tatika. Yes, you can do that as well. Then if I see how many times it is, I will divide this 1.8844 into 10 to the power minus 28 by the mass of an electron. Mass of an electron is 9.11 into 10 to the power minus 31. Correct? Which is 206.85 times. Which means, deduce whether this statement is correct. Yes, the statement is correct. Make a yes. The statement is correct. Two decimal places. No. Don't make it an extra pressure. Just give whatever you want. That was not my final answer. So before that, you can take whatever you want. Final answer, you can give it to about 3 significant figures. That should be enough. So anything more is also fine. Okay. Any questions, anyone? So you can convert mega electron volts over c square or giga electron volts over c square to kilograms. So if you want by any chance to convert kilograms to back to this, you should have to follow the reverse procedure. Correct? Let's see. Guys, from the MCQs, page number 52. Page number 52, question number 7. Page 52, question 7. Straightforward. A particle has a mass of 6.5 mega electron volts over c square. Which of the following gives the mass in kilograms of the particle? So 6.5 into 10 to the power 6.5 into 10 to the power 6 into 1.6 into 10 to the power minus
Sir,
19
the first one, sir. Others all are just rubbish.
over 3 into 10 to the power 8 square. That is how you confidently make mistakes. Okay.
No, see, so
Whoever
B is
decided the answer,
1.6 into 10 to the power minus 13. So that's definitely wrong. And
That
then
is
the
the
other C is wait, what?
this is how you confidently make mistakes. Calm down, calm down, calm down. Bro,
Ah.
calm down. Calm down. Hold back for a couple. Wait, listen. Here, see, listen. To convert 6.5 mega electron volts over C square to kilogram, 6.5 into 10 to the power 6 to convert mega electron volts to electron volts, into 1.6 into 10 to the power minus 19 to convert electron volts to joules, over 3 into 10 to the power 8 square. Do you agree with me? This is what we did in all the questions we did so far. Then it becomes 6.5 into 1.6. This 10 to the power 6 into 10 to the power minus 19 is, even your grannies will know, it's 10 to the power minus 13. Over 3 into 10 to the power 8 square. Now tell me what is your answer? Yusuf, where's your sound? What
So
happened?
my mic is not working, sir. My mic is not working.
B definitely no. Okay, so the answer is B. So don't jump into answers. You are not going to get any marks for selecting the answer in the shortest possible time. You can't go to the make a world record or something with deciding the answer in the shortest possible time. Take your time and decide the answer. Okay. The next one. Mm,
It also can do.
Hmm?
It also can do.
no, wait.
Common sense.
Page 67. Page 67, question 45. Is your answer?
The D.
Right, guys. A particle has a mass of 3.17 into 10 to the power minus 27 kilograms. Which of the following gives the mass in giga electron volts over c square? Now look at this. If you have the mass in giga electron volts over c square, if I take it as m, that multiplied by 10 to the power 9 into 1.6 into 10 to the power minus 19 over 3 into 10 to the power 8 square. This will give you the mass in kilogram, which is 3.17 into 10 to the power minus 27. Am I right? So the mass in giga electron volts is going to be 3.17 into 10 to the power minus 27 multiplied by cross multiply 3 into 10 to the power 8, that whole thing square, divided by 1.6 into 10 to the power 9 into 10 to the power minus 19. What is the answer? D. The answer is D. Okay. For a sixth one. Six. D. A gamma ray photon of energy 18 mega electron produces a particle and its antiparticle. Which of the following will give the maximum possible mass of the particle in kilograms? So guys, if I take the mass of the particle to be m into 3 into 10 to the power 8 square will give you the mass of that particle. Sorry, the energy equal to that particle. That is the particle and the antiparticle means I'll multiply that by 2. This is the total energy equivalent to their masses, which is supposed to be equal to 18 mega electron volts, which is 18 into 10 to the power 6 into 1.6 into 10 to the power minus 90. Correct? There is 80 mega electron volts of photon energy, which is what getting converted to 2 particles. So if I take the energy equivalent to those 2 masses, that should be equal to this 18 mega electron volts. Am I right? So if I take the mass of one particle to be m into c square, m into 3 into 10 to the power 8, the whole thing square, that is the mass of one particle, that multiplied by 2 will give you the mass, the energy of both the particles. That energy should be equal to the energy of the gamma ray photon, which is 18 into 10 to the power 6 into 1.6 into 10 to the power minus 90. Correct? So if I get the m subjected here, m equals, if I take the 2 to the other side, 18 divided by 2 becomes 9. 9 into 10 to the power 6 into 1.6 into 10 to the power minus 19 divided by 3 into 10 to the power 8, the whole thing square. Is there an answer like this? Give me a minute. Where is the answer? D. Yeah. Can you repeat your question? Is there anyone who can answer that question?
Since the mass, considering that the energy produced is 0.
After the,
Yeah.
very good. Because now we have taken that this entire 80 mega electron volts photon energy is only getting converted to mass. So the 2 particles produced have 0 kinetic energy after the production. If they had a kinetic energy, then that means the energy equivalent to the mass will be less than this one. Get it? So that means this is the maximum mass that can be produced. Understood? Right. Then, yeah, get back to the theory. Page number 5. The theory tube, page number 5. Not necessarily. Okay. The standard model. Not necessary. The standard model. After a century, in which scientists rapidly discovered many subatomic particles. They have now established the theory for how these come together to construct the things we see around us. This theory is known as the Standard Model. The idea of the atom as indivisible was swept aside by Rutherford and Thomson. And the idea of the proton and neutron as being fundamental has also been overturned. We have probed inside these two nucleons and discovered that each is constructed from smaller particles known as quarks. So back then, they used to think protons, neutrons, and electrons are the smallest particles. You can't break down it further. Okay, that's what they used to think. But now the latest theory says no, it can be further broken down into quarks and antiquarks. Okay, particles known as quarks. The electron is still considered the fundamental. The electron can't be broken down further, but anyway, it has two more partners, similar types of particles, and each has a neutrino associated with it, forming a group of 6 fundamental particles known as leptons. Scientists like to see the universe as balanced or symmetrical, and we have now found that quarks are also a group of 6, although only the lightest 2 are found in protons and neutrons. The heavier quarks are found in rarer particles. The two groups are different because quarks can undergo interaction via the strong nuclear force, but leptons do not experience the strong force. Highlight that part. Quarks can undergo interactions via the strong nuclear force, but leptons do not experience the strong nuclear force. The strong force is a type of force. It is the strong nuclear force that binds nucleons together in the nucleus. This type of force, known as the strong nuclear force, is what binding the nucleons together in the nucleus. In each group of 6, there are 3 pairs with a similar order of magnitude for mass, and these are known as 3 generations of matter. Okay, so guys, now these are the particles. There are 6 particles here and 6 more particles here. What are these? The first table, the table A, gives you the family of leptons. These do not experience a strong nuclear force. So what are the leptons? Electron, electron neutrino, muon, muon neutrino, tau, tau neutrino. Look at their charge. Electron has a charge of -1, we know that. Okay. So what is considered as 1 here is 1.6 into 10 to the power -19 coulombs. 1.6 into 10 to the power -19 coulombs is what considered as 1 here. So electron has a charge of -1. Electron neutrino, that doesn't have a charge. Muon has
So
a charge
according
of
to this, it has a mass of 0.511.
Correct. 0.511 mega electron volts over c square, which is an extremely small value. If you check it, if you convert this into kilograms and check, you will get that it's 9.11 into 10 to the power -31 kilograms. Okay.
Yeah.
And electron neutrino is even smaller. Okay. So muon has a mass of given, and it's the muon neutrino has a charge 0. Tau has a charge of -1, and tau neutrino has a charge of 0. So just remember, you don't have to remember anything, the entire table here. Just remember that electron belongs to a family of 6, which is known as leptons. Okay. And then there's another family of 6 particles. Okay. With quarks. This is a family of quarks. These are subject to strong nuclear force. The quarks experience a force called strong nuclear force. That's what keeps the nucleons in a nucleus combined together, binded together. But the leptons do not experience this force. And the 6 types of quarks are, there is a type of quark called up, down, strain, charm, bottom, top. So if you take protons and neutrons, they have these 2 types of quarks, up and down quarks. Okay. Let's continue from this point on the next day.
So physics is getting weirder, sir, day by day.
No, I know this topic is, guys, is a theoretical topic. But once you learn this, the questions will be same type. Once you know to answer these questions, it's an area to easily score. Might not be very interesting for some people, but that's how it is. Okay. Right. Bye. See you. Take care. What is your
Yes, sir,
question?
bye.
Subatomic particles, but quarks experience the strong force. Not same as electrons. Subatomic particles, both, but completely two different types. Okay. We'll speak about it for the next class.
Actually, even within the nucleus, there are like very few electrons, right? There are no electrons in the nucleus, right? But
How?
so because there had to be electrons.
Are you new? From which course? Okay. Today is your first day to your class. Then this will sound like Latin for you. You have to at least get the. We are actually now done with unit 4. Unit 4 we will be done in a few more weeks. Yeah. So try to manage it now. From unit 5 you will be able to understand. Okay.
So, like, but there had to be electrons in nucleus for protons to form, right?
Why?
Because electron plus proton produce